Okay, so now we're going to look at solving quadratic equations by completing the square. First we're going to look at a quadratic equation and solve it so that we know what the answers are, so we can compare this method. Okay, so in this one here, we know that we can factor it because the product, two numbers whose product is 15 that add to 8, okay, are 3 and 5. So the product sum method works here, and we can factor that directly from there. We don't need decomposition. We've got x plus 3 and x plus 5. And from what we know about solving quadratic equations by factoring, we know that the answer is -3 and -5. Okay, so those are the values that satisfy this equation, make it 0, and they'll also satisfy that. Now, if we take a look at this one here and we complete the square, okay, so this is another method, method 2 call it. So by completing the square, well, when we complete the square, we take half of that middle number here and we square it and we add it so that we have a perfect square. Okay, so if we take half of 8, it's 4. 4 squared is 16. Now we have a perfect square. We've got the 15 still there. In order to keep it the same as the previous one, we want to subtract 16. So that's the keeping it equal. Perfect square, keeping it equal. And we've got this. So now we've completed the square. Okay, now before we go on here, I want to go back to something over here that I've put aside. So when you have x squared equals 4, often what you want to do is just square root both sides and you get x equals 2. That's what you would have learned using the Pythagorean theorem, because you're only looking for positive answers. But if you think realistically about this, x squared minus equals 4, if you square positive 2 or negative 2, you will get 4. So those are both solutions. And you can see that from just by factoring. So if you got x squared equals 4, that's the same as x squared minus 4 equals 0. And you can now factor that. It's a difference of squares. So x minus 2, x plus 2 equals 0. And now you can see that x equals 2 and -2, okay, or plus or minus 2. So whenever you have something squared equals a number, then x equals plus or minus the square root of that number. Okay, so same thing happens if you have something like this: x squared equals 7, then x equals plus or minus the root of 7. Because when you square the root of 7, you get 7. Square the negative root of 7, you still get 7, because the negative becomes positive. In general, x squared equal to c, then x equals plus or minus root c. Okay, so this is going to help us when we're trying to solve by completing the square. So going back to this, now if we have x plus 4 squared minus 1, you can look at that as a difference of squares. So that's going to be x plus 4 minus 1, x plus 4 plus 1. Or you can bring the 1 over to the other side, so add 1 to both sides, and then get rid of the square root by going plus or minus square root of 1, which is just plus or minus 1. Okay, now you can subtract 4 from both sides. Minus 4, you get x equals -4 plus or minus 1, and so -4 plus 1 is one answer, and -4 minus 1 is the other. And if we do those operations, we get x equal to -3 and x equal to -5. These are the solutions that we got when we factored -3 and -5. So this is one example where it works. We have done everything mathematically correct, so this is a method that will work. Okay, another example of solving by completing the square, I'll show you right here, is something like this. Okay, half of 6 is 3, so I'm going to square 3, which is 9, add it, subtract it, keep the 4 there, complete the square. X minus 3 squared equals 5 by bringing the 5 over, Okay, x minus 3 equals plus or minus root 5. And then x equals 3 plus or minus root 5 by bringing the negative 3 over, being positive 3, adding 3 to both sides. You get this. Now you've got two solutions. X equals 3 plus root 5 and 3 minus root 5. So the power of this is that you can't get these numbers by factoring. Because these are irrational numbers, they're going to give you decimal numbers. You can't do this by factoring. So this method of completing the square is more powerful than factoring. Okay, so this will work all the time. I'm going to show you a couple more examples. So I'll show them to you, and then you can pause and try them and see what you get, and then I'll show you the solutions. Okay, so here is another one that you could try. So you pause and try it. Okay, now here's the solution to it. And a little bit more here. Okay, so that's the solution. Now you could plug those into your calculator and get approximate answers, but these are exact. Okay. Here's another example. Give you a try. You try this one. I'll show you the solution in just a second. Okay, so you can pause it and try it. Now here's the solution. So with this one, when you bring the negative or the 2 over, it becomes negative 2. So subtracting 2 from both sides gets you negative 2 here. Now you've got to take the square root of negative 2. Well, you can't take the square root of a negative number because no number multiplied by itself will ever be negative. So this is not possible. This is a case where there is no solution. And this will tell you that. Okay, so by factoring, you can't tell whether there's going to be a solution or not. Well, if you can't factor, it doesn't mean there's no solution. It just might mean there's decimal solutions. In this method, when you get to the point where you take the square root of a negative, well, then you can't, so there is no solution. Okay. So that's that one. Here, I'll give you a few more examples to try. So there are some examples that you could try, and I'll show you the answers here in a second, so you can pause, write those down, and then I'll go through the solutions. Okay, the solutions are coming now. So here is solution to the first one. Pause it and write it down if you want. Solution to the second one. It's number 2. Third one. Okay, so got that, and the fourth one. It's a little bit messier here at the bottom. Okay, and that's what you get for those.